Sharing of charge between two conductors. Case 1. Common potential difference V is equal to C1 V1 plus C2 V2 upon C1 plus C2. Decrease in electric potential energy of system is equal to Uy minus Uf is equal to C1 C2 upon 2 C1 plus C2 in bracket V1 minus V2 whole square. Heat produced in circuit is equal to decrease in EPE of system C1 C2 upon 2 in bracket C1 plus C2 in bracket V1 minus V2 whole square. Case 2. Common potential difference V is equal to C1 V1 minus C2 V2 upon C1 plus C2 C2. Decrease in electric potential energy of system is equal to Uy minus Uf is equal to C1 C2 upon 2 in bracket C1 plus C2 in bracket V1 minus V2 whole square. Heat produced in circuit is equal to decrease in electric potential energy of system C1 C2 upon 2 in bracket C1 plus C2 in bracket B1 minus B2 whole square. Case 2. Common potential difference V is equal to C1 V1 minus C2 V2 upon C1 plus C2. Decrease in electric potential energy of system C1 C2 upon 2 in bracket C1 plus C2 in bracket V1 plus V2 whole square. Heat produced in circuit C1 C2 upon 2 C1 plus C2 in bracket V1 plus V2 whole square. Series combinations in general is equal to 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus and so on. In integral form 1 upon C equivalent is equal to integration 1 upon dc B1 is equal to C2 upon C1 plus C2 into B. V2 is equal to C1 upon C1 plus C2 into B for two capacitor. Parallel combination in general integral form C equivalent is equal to C1 plus C2 plus C3. C equivalent is equal to integrations del C. In parallel combinations, charge divided among capacitor Q1 is equal to C1 upon C1 plus C2 Q. Q2 is equal to C2 upon C1 plus C2 Q. Wheatstone bridge arrangement of 5 capacitor C1 upon C2 is equal to C3 upon C4. Conditions for balance Wheatstone bridge: X is equal to minus B plus minus in under root B square minus 4AC upon 2A. Dielectric electric field inside capacitor E is equal to Q upon epsilon naught A minus Q is equal to Q upon K epsilon naught A. K is equal to if is property of matter potential difference between plates of capacitor. B is equal to ED is equal to QD upon K epsilon naught A. Capacitance of capacitor C is equal to Q upon V is equal to Q upon QD upon K epsilon naught A. is equal to in bracket k epsilon naught A upon QD into Q C is equal to k epsilon naught A upon D. Dielectric of thickness T is flashed inside capacitor. Dielectric change induced on the surface of dielectric Q dash is equal to Q in bracket 1 minus 1 upon K sigma dash is equal to sigma in bracket 1 minus 1 upon K. Q dash is equal to induced charge sigma dash is equal to induced surface charge density. Q is equal to charge on capacitor. Sigma is equal to charge density on capacitor. Force between plates of parallel plate capacitor. F is equal to Q square upon 2 epsilon naught A. Pressure is equal to F upon area is equal to Q square upon 2 epsilon naught A upon A is equal to Q square upon 2 epsilon naught A square is equal to 1 upon 2 epsilon naught in bracket Q upon A whole square is equal to sigma square upon 2 epsilon naught. Cylindrical capacitor C is equal to 2 pi epsilon naught L upon ln in bracket B upon A. Breakdown voltage V is equal to ED P dot B is equal to in bracket D dot S into D. Unit of D dot S is equal to n upon C. Dielectric strength or V upon M